Fingers get fingers. Good morning, students. Good morning to all. We are CHEM from Hyderabad. Last class में हम देखे थे JEE Mains का syllabus. So we have seen in the last class the JEE Mains 2024 syllabus, and in that I have explained to you. मैंने आपको पढ़ाया है कि हमने देख चुका है कि फिजिकल में 8 यूनिट से, इनऑर्गेनिक में 4 यूनिट से, ऑर्गेनिक में 8 यूनिट्स. That means here we have seen in inorganic 4 units are there, physical 8 units are there, and in organic we have 8 more units are there. Now today we are going to take one topic from physical chemistry, that is thermodynamics. While discussing, I have already told you to that ये जो है नॉट ओनली रिलेटेड टू केमिस्ट्री, ये जो बेटा हम फिजिक्स में भी पढ़ते हैं. दैट्स व्हाई दिस टॉपिक इज वेरी वेरी इंपॉर्टेंट, एंड यू हैव सीन मेनी रिलेशंस ऑफ दिस रिलेटेड टू थर्मोडायनामिक प्रॉपर्टीज, थर्मोडायनामिक पोटेंशियल्स एंड द वेरिएबल्स. नाउ आज मैंने पहले वीडियो में बोला था कि ये जो है द पर्पस ऑफ स्टार्टिंग दिस एकेडमी इज, ये जो ऑलरेडी मैं ये तो बोल चुका हूँ. I already explained to you, I already told you that you will be having chemistry teacher in your college, and you have that you have the even you have the textbooks are there. आपका स्टेट बोर्ड या नए से सीबीएसई का तो बोर्ड से, और आपका ये टॉपिक जो है कुछ टॉपिक जो है ये यूट्यूब में भी वीडियोस अवेलेबल है. और जरूर अभी व्हाट इज द नीड ऑफ द टेकिंग वन मोर स्टार्टिंग दिस एकेडमी इज, जो एक्स्ट्रा आपको चाहिए वो हम इधर देने वाले हैं. सो यू कैन, आई ऑलरेडी टोल्ड यू कैन बी फ्रॉम either from north eastern state, or from Gujarat, or from Ladakh, or from Kerala. Here you will need not to feel that ये तो टफ है, मुझसे नहीं हो पा रहा है, ऐसा कुछ भी नहीं बेटा. हम जो पढ़ाने वाला है इधर आपको सिंपल तरीके से straightly will go to the topic, and we are going to discuss how to solve the problems also. Now example today, for example today I will start the topic with thermodynamics. Now in this I think you have discussed, you know these variables like S, you know beta entropy, P pressure, V value, T temperature. So these are the variables, and also you know the internal energy U, enthalpy H, Gibbs energy G, and Helmholtz energy A. Now you have seen this is there in your first year, right, in 11th standard. Now you have seen this relation between different variables and functions also. Now here this is a new one to you. Here we are good. Here आप क्या देख रहे बेटा, आप जो ये देख रहे हैं ये सिंपली ये तो ये है स्क्वायर, वन स्क्वायर. नाउ इसके कॉर्नर्स पे है एंट्रोपी, प्रेशर, वैल्यू, टेम्परेचर, एंड इसका साइड्स पे है, आप ये देख सकते हैं इधर इस तरफ है इंटरनल एनर्जी. सो यूजुअली वी डिनोट द इंटरनल एनर्जी विद U or E, but many times we are using only U. Now here on this side U is there. Now here enthalpy is there, here Gibbs free energy is there, and here यहाँ पे है Helmholtz energy. Now so आपको अभी है ये जो है सिंपल थर्मोडायनामिक स्क्वायर. नाउ इससे हम क्या करेंगे बेटा, इससे हम डिराइव करेंगे 20 रिलेशंस, 20 relations we are going to derive from this simple thermodynamic square of different the relation between the relations of the different thermodynamic functions and variables, thermodynamic potentials and variables. Now we'll see. So let's start. Now ये जो डायग्राम है ध्यान से देख लो बेटा, ये जो डायग्राम है थोड़ा ध्यान से देख लो. ओके, नाउ हियर दिस इज नथिंग बेटा, ये जो सिंपल आपको दिखाई दे रहा है एक स्क्वायर था और स्क्वायर के 4 कॉर्नर्स पे है entropy, pressure, value, temperature. Now on sides with the internal energy U, enthalpy H, Gibbs energy G and Helmholtz energy A. Now आपको दिखाई दे रहा है बेटा ये arrows, a diagonal arrows. Now ये arrow शुरू हो रहा है और ये जो शुरू हो रहा है प्रेशर से वैल्यू. Now we are going to derive. मैंने ऑलरेडी बोल चुका हूँ कि आपको ये सिंपल डायग्राम से हम 20 thermodynamic relations we are going to derive. Now let's go. Now so you know beta, U is internal energy, H is enthalpy, G is Gibbs energy, A is Helmholtz energy. Already we have seen variables are S is entropy, P is pressure, V is value, T is temperature. Now from this diagram we are going to derive functions. We are going to get the relation of that functions, partial differential equations and also Maxwell relations. Now, first we will see the functions. ये देखो बेटा, ये पे है ना, यहाँ पे ये थर्मोडायनेमिक पोटेंशियल है ना U और H, G, A. ये क्या है? ये जो पोटेंशियल है, it is depending on the variables present on that side. So that means if the meaning of that one is Gibbs energy is the function of pressure at T variables. Now like that, enthalpy is the function of entropy and pressure, S and P. So उस तरफ जो variables है वो thermodynamic potential उस पे dependent है. So उसका function. So like that, G is the function of P and T, H is the function of P and S, U is the function of S and V, A is the function of volume and temperature. So like that, if we see, थोड़ा ये आप पेपर पे लिख दो, आप पेपर पे लिखे तो अगला टॉपिक्स आपको can understand easily. Now, just remember on four corners SP, VT are there, four sides U, H, G, A is there, U, H, G, A are there, and there are two diagrams like this. Arrow marks, one is starting from P to V and another one is from S to T. Now, I already told you, first we are going to derive functions. Internal energy. Just you check beta. Internal energy is 0. So it is a function of variables S and V. So that is the first relation. So internal energy U is the function of S and V. That is the first. Next, number 2, H. H you know beta, enthalpy. Enthalpy is a function of S and T. Like that, G is a function of P and T. So G is a function of P and T. That is the third relation. Like that, A is a function of volume and temperature. So Helmholtz energy is a function of volume and temperature. So now till now we got 4 important relations. These are important for your JEE Mains and also for your NEET examinations. Okay. अभी जो आने वाला है वो तो एडवांस्ड में भी आएगा और मेंस में भी आएगा. Next we'll from the same diagram, from the same simple सा square से we are going to derive partial differential equations, that is partial derivatives. So as आपने पढ़ा हुआ गिब्स एनर्जी पढ़ा हुआ है, वहां पे क्या लिखेंगे आप you have seen one equation there, dou G equals to, that is del G equal to V del P minus S del T. Otherwise dou G equal to V dou P minus S dou T. ये तो आप derive कर चुका है. Now, how to get that one? Like that, not only for Gibbs energy, like that we can calculate for enthalpy, dou H, del H. We can calculate the partial differential value of H. and also Gibbs energy, and also Helmholtz energy, and also the last one, this internal energy also. Okay, now we are going to derive partial derivatives, that is partial differential equations of these four thermodynamic potentials. What are those four thermodynamic potentials? One is the internal energy U, another one is the enthalpy H, third one is Gibbs energy G, fourth one is A. Then how to get? So this is a shortcut better. How to get the direct equation? Simply what you have to do is, suppose we are differentiating this thermodynamic potential. That means I want to find out the del G or dou G. Now what you have to do? We have to differentiate the respective variables present on that side. That means dou P, dou T. Suppose say this first one is P is there, dou P. It should be multiplied with opposite variable V dou P. And this one dou T, I already told you. We have to differentiate the respective variables, followed by multiplication of opposite variables. So here for this dou G or del G, we are going to get del P, we will get our plus or minus del T. Dou G equal to dou P, dou T will be there, followed by multiplication. Now we have to get the dou G, here already dou P is there, it should be multiplied by V dou P. Like that, here dou T is there, it should be multiplied by S del T. That means dG is a combination of, that is dG is a summation of that V dou P and S dou T. But what are the signs? Whether it is a plus sign or minus sign? How to find out? Here two variables are there. We are calculating the partial differential equation with respect to G. That's why we have to consider these two variables. Now for this variable, arrow mark is away. That means we have to keep plus sign before this one. Whereas for this one, arrow mark is towards the temperature. That's why we have to keep the minus sign. So simple thing to get the partial derivative of any one of these four thermodynamic potentials. What are the four thermodynamic potentials? G, H, U, A. We have to differentiate the respective variables, that is partial differentiation. We have to differentiate the partial, that is respective variables, followed by multiplication. And before that is we have to keep the plus or minus sign before those values by seeing whether arrow mark is away from the variable or towards the variable. If the arrow mark is away from the variable, we have to keep plus sign before that. If arrow mark is towards the variable, we have to keep minus sign before that. Now if that is the case, I can write del G equal to V dou P. It is said with plus. Why plus? Arrow mark is away from. So V del P. We already discussed it should be S dou T or S del T. But here arrow mark is towards the variable. We have to keep minus sign before the S del T. So now the equation becomes del G equal to V del P minus S del T. Like that we are going to get. Is that clear? Clear beta? To get the partial differential equation of any one of these thermodynamic potentials, what we have to do is, we have to differentiate the respective variables, followed by multiplication with opposite variables, and we have to keep the sign by seeing whether the arrow mark is away from the variable or towards the variable. If arrow mark is away from the variable, we have to keep the plus sign before the term, and if the arrow mark is towards the term, we have to keep minus sign before the term. Just you keep this one in mind. Now, like that we are going to get one relation. Here one more relation. Here one more relation. Here. Now try to get. Now we will see. So what are the rules? While differentiating thermodynamic property, corresponding variables should be differentiated and these should be multiplied by opposite variables. Next, अब जो प्रॉब्लम आता है साइन के बाद. If arrow mark is away from that variable, we have to keep plus sign. If arrow mark is towards the variable, we have to keep minus sign. Now like that we got like that we have seen, I have discussed this with the example of Gibbs energy, like this, dou G equal to V dou P minus S dou T. Like that, in every case, we are going to get the partial differential equations. Now, first one we are seeing is dou U. Now you see here, S is there. Now to get the partial differential equation of internal energy U, we have to differentiate these respective variables, dou S, dou V. Now if you see here, T dou S, and arrow mark is away, that's why we will get plus sign before the one. And here minus P dou V. And here y minus, because arrow mark is towards the V. Okay, that's why we are getting T dou S minus P dou V. So that's why we are getting T dou S. That means del U we are getting T del S minus P del V. So this is the equation 5. So like that we are getting relation 5. Now again from this we are going to get two more relations. These are important for your JEE Mains as well as for your NEET exam, also very, very important, and also for advanced also very, very important. Now if you see here, from relation 5 we are going to get two more relations. If you see, just see here T del S is there, P del V is there. Now if I keep the value mass constant, del V will be 0. So that this term will be 0, and we are going to get dou U at constant value is T dou S. And if you take this del S towards left side, dou U by dou S at constant value is T, temperature. ठीक है बेटा? Are you following or not? Yeah. Okay. Now we got dou U by dou S at constant value is T. Now like that we won't get, so these are equation 6. These are relation 6. Now we will get one more relation from this equation. How? Suppose if entropy, that is entropy is kept constant, that is dou S is constant. Now what will happen? Automatically this term will be 0. Here that is a constant entropy, this term will be 0, dou U equal to minus P dou V. So if we take this del V to the left side, at constant entropy we are going to get minus P. That is the seventh relation. So dou U by dou V at constant S is minus P. Okay, ठीक है बेटा? Yeah. These are very, very important for your, not only for your chemistry and also for your physics also, very, very, even in NEET also very, very important. Now, like that, another thermodynamic potential H. Now H, you see better. H, that means this one. Now if you see here, these respective variables should be differentiated, followed by multiplication of opposite variables, and we have to keep in mind that if arrow mark is away, we have to keep plus sign before that. And if arrow mark is towards, we have to keep minus sign before that. Now here if it is, we are going to find out del H. It should be del S del P. It is T del S plus V del P. Here both are plus. Why? Because both the arrows are away from the variables. That's why we are going to get T del S plus V del P. So this is the second one. We'll see here. Del H equals to T del S plus V del P. So this is the 8th relation. And again we are going to get two more relations. From this we are going to get two more relations better. How? Now you see here again it can be at constant entropy or at constant pressure. Now if it is at constant pressure, you know that this term will be 0. Difference will be 0. So if it is, this difference is 0, automatically this value will become 0. So now we are going to get dou H equal to del H equal to T del S. Now dou H by dou S, if I take this one to the left side and it is at constant pressure, will be equal to temperature. So this is a 9th relation. So this one is a 9th relation, right? इससे पहले आप पढ़ चुके हैं क्या ऐसा? Yeah, that's why we started CHEM G. We have started CHEM G, right? Now these are very very important for your advanced also, right? Now next we'll move to the here again. I already told you. Again, we can also keep the entropy also constant. If entropy is constant, del S will be 0. If del S is 0, we will get del H equals to 0 plus V del P. Now, if we take del P to the left side, del H by del P at constant entropy is value. So this is the 10th relation. 10th relation. See beta, एक simple सा diagram. एक simple सा diagram से we are deriving 20 relations. We are deriving 20 relations which are very very important for your NEET Mains Advanced, right? अभी अब तक हम कर चुके हैं बस 10. We have solved till now only 10 और 10 बाकी है और 10 we are going to see. Like that. We are already told in the first case when I have told the partial differential equation of this Gibbs energy del G equal to V del P minus S del T. This is a relation 11th. These are very important for your NEET. Now again from this we are going to get two more relations. How? Now आपको समझ हो चुका है. How? You see here. We can keep the either temperature constant, either pressure constant. Now if I take the temperature as constant, del T will be 0. If this term will be 0, automatically dou G equal to V del P. Now if I take this del P to the left side, del G by del P at constant temperature is value. This is a 12th relation. This is a 12th relation. Now continuation to that one. Now just now we kept temperature as 0. Now we are going to kept pressure as 0. Now if we keep that pressure as 0, that means at constant pressure del P will be 0. Now what happens, beta? This del P is 0, so automatically this term will be 0. So we are going to get del G equal to minus S del T. That is at constant pressure. So we will get the relation like this. Del G equal to 0 minus S del T. Now that means here, if I take del T to the left side, del G by del T at constant pressure is minus entropy. Asan hai beta, 13th. So that is a 13th relation. So till now we got 13th relation. Now another function is also there, another potential is also there, thermodynamic potential, that is Helmholtz energy, denoted by A. Helmholtz energy denoted by A. Now for this also, if you look at the diagram, here in this case you are going to see both the minus values. Here you are going to get both minus values. Now to get the partial differential equation of that Helmholtz energy, we have to why? Because this Helmholtz energy is a function of volume and temperature. That's why we are differentiating with the respective variables, that is del V, del T, multiplied by opposite variables pressure, opposite variable entropy. जस्ट आप एक बार, इसीलिए मैंने बोला था कि एक बार पेपर पे लिखो. Now why two minus are there? Because if you see towards V also arrow is there, towards T also arrow is there. That's why in both the cases we are getting minus sign. In both the cases we are getting minus sign. So that's why in the equation, in the relation 14, del A is equal to minus P del V minus S del T. Now आपको समझ में आया? अभी क्या करना है? अभी हम ये 14th equation से, 14th relation से we'll get two more. How? We can keep the temperature as constant, or otherwise we can keep the volume as constant. Now if I keep this temperature as constant, see better. If we keep the temperature as constant, this term will be 0 minus P del V. So dou A equals to minus P del V minus 0. That is dou A equal to minus P del V. Now dou A by dou V, if I take this dou V to the left side, and since it is at constant temperature, we are going to get the minus pressure. Okay, clear about it, right? So this is the 15th one. Now we are going to get one more thing. We'll get one more. How? Just so we kept temperature as constant. Now we can keep also volume as also constant. Now if we keep volume as constant, this term will be 0. So this will be 0. Dou A equal to minus S dou T at constant value. Now you see it. अभी A जो है ना. So like this they will ask you in JEE Advanced and JEE Mains. Okay, these are very important for you. Whereas partial differential, the total equation is important for your NEET. Whereas here for JEE Mains and also for JEE Advanced also very important. Now, so they'll directly give it like this. Dou A by dou T at constant value is minus S. You can frame n number of multiple choice questions बेटा. यहाँ पे आप जो है n number of multiple choice questions आप प्रिपेयर कर सकते हो. ओके, नाउ सो दिस इज द 16th रिलेशन. सो अभी तक हमने 16 रिलेशंस वी हैव गॉट ओनली फ्रॉम सिंपल थर्मोडायनामिक स्क्वायर. क्लियर बेटा? नाउ हम चलेंगे अभी ये जो आने वाला है JEE Advanced में आएगा. We'll get 4 more relations and those are called Maxwell relations. 4 relations will be there. So those 4 Maxwell relations also will get from the simple thermodynamic square. Now चलेंगे, अब हम चलते हैं Maxwell relations. Now इससे पहले हम just write again the same thermodynamic square. We are writing a simple thermodynamic square. 4 columns पे है, वो एंट्रोपी है, प्रेशर है, वैल्यू है, टेम्परेचर है, बस इतना अच्छा. और 4 साइड्स पे है इंटरनल एनर्जी, एंथैल्पी, गिब्स एनर्जी, हेल्महोल्ट्ज एनर्जी. और इससे अलावा और दो भी है, वो है एरो मार्क्स. एक एरो चल रहा है, P is moving from P to V, another arrow is moving from this entropy to temperature. Another arrow is moving from entropy to temperature. Now, to get the Maxwell relations, we have to consider opposite sides. Now, A है square. Square will be having 4 sides. 4 sides means how many opposite sides? Two pairs. 2 pairs of opposite sides, right? Like this we can take like this opposite one opposite pair, or otherwise like this we can take. Now simple सी बातें है. अभी जो हम opposite sides U और G ले रहे हैं, so we can take U और G, opposite sides U and G, or otherwise opposite sides H and A. Now first we will take U and G. Now how do we get this one by this one? Partial differential. Difference value of this one by this one is equal to this one by this one. So we'll get 2 opposite pairs like this, U and G or H and A. Now if I take U and G, dou S by dou V is equal to dou P by dou T. This one by this one is equal to this one by this one. Dou S by dou V is equal to dou P by dou T. बस इतना चाहिए? नहीं, वो कौन सा वेरिएबल कांस्टेंट है? हाउ टू फाइंड आउट? जो न्यूमरेटर में हम ले रहे हैं ना, उसका अपोजिट में जो वेरिएबल है वो कांस्टेंट है. Dou S by dou V at constant temperature. Like that, dou P by dou T at constant. क्या न्यूमरेटर जो है बेटा प्रेशर. So ये एक प्रेशर अपोजिट वेरिएबल है V. So that's why V is constant. So dou S by dou V at constant temperature is equal to dou P by dou T at constant value. Now what about the signs? यहाँ पर भी signs, whether it is positive sign or negative sign, we have to consider only numerators only. If arrow mark is moving away from the numerator, plus sign. If arrow mark is moving towards the numerator, minus sign. Now here the first case numerator is dou S. arrow mark is away, plus sign. Second case, that is a dou P by dou T. So here also arrow mark is moving away. That's why in both the cases we are going to get positive sign. That means what is the first Maxwell relation? Dou S by dou V at constant temperature is equal to dou P by dou T at constant value. Both are positive sign. This is the first relation. Now this one by now we will change the exact reverse manner. Now we are taken S by V. Now we will take V by S. Since we are considering opposite sides, in the first case we have taken S by V equal to P by T. But here now we take V by S equal to T by T. Now just like that बेटा, अभी जो है हम लेने वाला है second relation, Maxwell second relation, dou V by dou S equal to dou T by dou P. Why? Because we are considering opposite weights, that is opposite sides, U and G. So now this one by this one equal to this one by this one. Now what about the positive and negative signs? Now dou V by dou S, since our numerator, I already told you better, we have to consider only numerator. Now in both the cases numerator is this. In both the cases we are getting minus. Dou V by dou S. Why? Because numerator is dou V. Again arrow mark is towards V, hence minus sign. Like that, arrow mark is dou T by dou P. Arrow mark is again towards T. So minus sign. So both minus will be get cancelled. So that again we are going to get positive. So dou V by dou S at constant pressure is equal to dou T by dou P at constant entropy. That is the Maxwell second relation. Here, the opposite sides U and G we are going to get, in both the cases we are getting, if you see here, in both the cases we are getting positive sign. In the 17 mein to already both are positive. In 18 mein both are negative, both are get cancelled. That's why both are again positive. So dou S by dou V at constant temperature is equal to dou P by dou T at constant value. This is the 17th relation. And this is also called Maxwell 4 relation. First one, Maxwell relation 1. Now second one is upside down. That is like this. Dou V by dou S equal to dou T by dou T. But the opposite variable is here, it is pressure. Here it is entropy. Here, since if you see here, if you see the thermodynamic square, in the case of dV and dt, both are negative. But since both are negative, we are getting again positive values. Okay. So this is the 18 relation 18 here. Okay. AB Maxwell second relation. Now these two we got by considering opposite potential, thermodynamic potential U and G. Now we have to take the opposite. Just now we have taken this one U and G. Now we have to consider opposite H and A. So if we take opposite sides like this, now this one by this one equal to this one by this one. Okay, dou S by dou P equals to dou V by dou T. Now dou S by dou P equal to dou V by dou T. Now dou S, we have to always consider numerator in case of sign, in case of constant. Now here the first one is dou S, so opposite variable will be temperature will be constant. So dou S by dou P at constant temperature is equal to dou V by dou T. And here opposite variable is pressure. So dou V by dou T at constant pressure. Now what about the signs? Since dou S, arrow mark is away from the S, positive sign. Arrow mark is towards the value, that is dou V. So it is minus. So minus dou V by dou T at constant pressure. In this case, in the case of Maxwell third relation, we are going to get dou S by dou P at constant temperature is minus dou V by dou T at constant pressure. So here we will get one plus value, one minus value. That is a Maxwell third relation. That we'll see, that is 19th equation, 19th relation. Now, just like we have seen this one by this one equal to this one by this one. Now, this one by this one is equal to this one by this one. Now dou P by dou S is equal to dou T by dou V. Why? We are considering the opposite H and D. Opposite side is H and D. Now dou P by dou S equals to dou T by dou V. Dou P by dou S, since numerator is pressure at constant value. Now dou T by dou V, opposite value is numerator S. So S. Now here dou T is, the arrow mark is towards the dou T, we will get minus sign. So that's why dou P by dou S at constant value is equal to minus dou T by dou V at constant entropy. That is the equation, that is important relation 20. Now we'll see one. So by considering the opposite sides H and A, we'll get like this. One is plus value, another one is minus value. So dou S by dou P at constant temperature is equal to minus dou V by dou T at constant pressure, which is the 19th relation. Okay, these are very important for your JEE Advanced and NEET. Now, like that, upside down, that is dou P by dou S at constant value means again we are getting minus sign. Why? Because arrow mark is moving towards the temperature, dou T by dou V at constant entropy. This one is the 20th relation. ये है बेटा thermodynamic simple सा square है, 4 corners है, 4 sides है, 4 thermodynamic potentials है, 4 variables है. From this we have derived important 20 relations which are very important for your JEE Mains 24, NEET 24 and also JEE Advanced 24.